Greetings, this is Najla. We will keep talking about ferritin molecule, and today we will learn together about ferritin isoforms. Before I go further, I'd like to ask you again to put this video on pause and try to answer the questions underneath. When you finish, you come back and watch it. Ferritin has two isoforms, known as H-ferritin and L-ferritin. It's also known as heavy chain and light chain, or in the last video we called them H subunits and L subunits. Now it's very important to know that there is no pure ferritin consists of only L form or H form. They always come together, but the ratio varies based on the tissue. H stands for heart tissue, and it is heavy isoform based on electrophoretic migration. L stands for liver tissue, and it is light isoform. H-ferritin is iron-rich. L-ferritin is iron-poor. The reason why H-ferritin is iron-rich is related to peroxidase activity. Remember from previous video we said ferritin molecule is capable of storing iron only in ferric state. Ferric state is iron soluble and non-toxic state. So peroxidase activity, that means convert ferrous Fe+2 to ferric by adding one electron. L-ferritin lack for peroxidase activity, and that's why it cannot store iron and it is iron poor. Also, it's worth mentioning here that heart tissue rich with ferritin that has high ratio of H-ferritin in it. And it is very important, and thank you for Mother Nature for this in particular equation here, because cells deficient on ferritin H are more susceptible to oxidative damage, while increased amount of ferritin H protects cell from death induced by challenges such as iron, tumor necrosis factor, or oxidized low-density lipoprotein. So it is a kind of protection mechanisms from Mother Nature to protect our heart tissue, heart cells. Fascinating. Genes encoding the H subunit are located in chromosome 11q part, while the L-ferritin, the L subunit, are located in chromosome 19q part. I'll come back later and explain to you how you guys can never mix up those small tips that easy to mix and easy to forget. Both H and L subunits have multiple pseudogenes. Pseudogenes are genes lost their function to code protein. This is normally occur due to multiple mutations. When they become pseudogenes, they be similar like non-coding DNA, and their function is regulatory. Both H and L have 50% amino acid sequence similarity between them. H-ferritin can suppress myelopoiesis. Myelopoiesis is a production of any cell line in bone marrow. So H-ferritin can decrease significantly the proliferation and the number of granulocytes, macrophages, erythrocytes, megakaryocytes, and multipotential progenitor cells. L-ferritin has no effect on myelopoiesis. H-ferritin can selectively inhibit the delayed hypersensitivity. I'd like to refresh your memory with hypersensitivity reaction. There are 4 types of allergic reactions or hypersensitivity reactions. Type number 4 is the delayed hypersensitivity one. Type number 4 itself subdivided into 3 groups based on the immune reactant. T helper 1 cells is group 1, T helper 2 cells is group 2, and cytotoxic lymphocyte is group 3. Now the question that easily come to mind is, which one ferritin is able to inhibit? Is it 3 of them, or is it 1 of them, or 2? What's the mechanism? I don't know. If you know, please share with us your information in the comment section below, with a big thank you to you. L-ferritin has no effect on delayed hypersensitivity. H-ferritin thought to induce production of interleukin-10. I'd like to draw your attention for this particular point because we will come back to it in details later when we speak about H-ferritin and immunity. Meantime, all you need to know is interleukin-10 is anti-inflammatory cytokine that can inhibit cell-mediated immunity and enhance humoral immunity or antibody production through B cell. L-ferritin doesn't induce a production of interleukin-10. H-ferritin has immune modulatory role. That means it can modulate immune response. H-ferritin plays an important role in chemokine receptor-mediated signal transduction and migration. Don't be scared of the word signal transduction. Simply it means cell signaling. And normally this occurs when there was a molecule bind to cell receptor. There will be a special video focused on ferritin cell receptor. I encourage you again here to subscribe so you won't miss it when I upload it. I hope it will be not too long to upload. Back to clarify the point. Ferritin is capable of transmitting the molecular signaling from cell's exterior to its interior, leading to appropriate response such as protein kinases, phosphorylation, and I can give you simply example that we just mentioned here, that ferritin H thought to induce production of interleukin-10. Interleukin-10 is a protein, of course. L-ferritin, no immune modulatory role reported. That leaves us with the function for L-ferritin is protein stability and iron mineralization. And I would recommend you to stay tuned for the next video because I will cover the iron mineralization and enucleation in the ferritin molecule. Now the ferritin isoforms comparison done from my side. It's your time to go back to the question section again. Try to answer the questions for the second time. This will help the information to stick in your head for a longer time, and also it will show you how these few moments made a difference in your knowledge in terms of ferritin isoforms comparison. Until next coming video, wish you a great time. Bye-bye.